All right, so let's review the kinds of things that we need to know for standard EF. All right, so standard EF was, just a sec, let me grab a pen. So we're going to talk about standard EF, and that was 3-1, 3-3, and 4-1. So we'll kind of go in order from 3-1 to 3-3 to 4-1, so it kind of flows in the way that you learned these items. All right, so 3-1, we talked about linear equations. All right, so a linear equation or linear equations can be written in this form, ax plus by equals c. And this form right here, that is called standard form. Right? It has a name because there are other forms that we talk about. All right, in this form, so I'll put that down here, x and y are variables, and they are referring to different values that you can have in a point. Because if you think of a coordinate plane here, we have an x-axis and a y-axis. Any point has an x value and a y value. All right, so the numbers in your point, x, y, those are solutions to your linear equation, your x value and y value that'll make this true. And then the a, b, and c are just numbers. Okay? So examples of a linear equations would be 3x minus 2y equals 18, y equals 9, x equals 1/3. Okay, so this one's pretty easy to see how it can be in this form. A is 3, B is -2, C is 18. This isn't as easy to see, okay? So we don't have an x here. That's because our value of A is 0, because 0 times x is 0. So that's why it just doesn't show up. Value of B would be 1, because we have 1y equals 9. So then for this one here, this would also be a linear equation where there's a 1 in front of x, because it's 1x here, and then the y is not showing up. So there's a 0 in front of the y, and then c is 1/3. So with linear equations, you're not going to see, okay, so let's write it like this. So non-examples, you're not going to see any squares, okay? You're not going to see that. You won't see this, okay? No squares on the y's, no squares on the x's. You're not going to divide your variables. You will not multiply your variables, okay? These are all non-examples. These are not linear. Okay, so let's write that in here to clarify that. Okay? So after talking about that, we're going to talk a little bit about linear equations on graphs, okay? So if I drew a graph here, a linear equation is always a line. Okay? So there's a line on a graph, x-axis, y-axis. These 2 points here have special names. So this, that is my x-intercept. Okay? So the x-intercept is the x value of the point where a graph crosses the x-axis, okay? So intercept and x-intercept meaning cross, okay? Or intersect. Okay, so the x-intercept is where my graph crosses my x-axis. So if I follow these together, they come together at that point. So then my y-intercept is exactly what it sounds like. Okay? My y-intercept is where, in reference to this, where it crosses the y-axis. And I should have add this in, y value at that point. It's only the y value at the point because the x value, okay, this is really important here. The x value on my y-intercept is always 0. And for my x-intercept, the y value is always 0, okay? This becomes really important when we talk about finding x and y intercepts, okay? So let's find the x and y intercept of 2x plus 6y equals 12. All right, so to find the x-intercept, what you're going to do first is set y equal to 0. Okay, so I'm going to come over here. I'm going to do 2x plus 6, not 6y, saying y is 0. Equals 12. Okay, so that's what I do first. My second step is to solve for x. So if I solve for x here, 6 times 0 is 0. So I have 2x plus 0 is 12. 2x plus 0, well, that's just 2x. I can divide by 2, and I get x equals, right, that'll cancel. 12 divided by 2 is 6. Right? So my last step, okay, so this goes with that step, that goes here. My last step is just saying x is the x-intercept, okay? So my x-intercept would be 6. So then to find my y-intercept, it's the same exact idea. My first step is to set not y equal to 0. On the y-intercept, x is 0. So I'm going to set x equal to 0. So if I do that, get another color pen out here, I will have not 2 times x, because I'm saying x is 0, so 2 times 0 plus 6y equals 12. Next step, we're going to solve for y, okay, because now y is the only variable left in this equation. 2 times 0 is 0. 0 plus 6y is 6y. Divide by 6 on both sides, so it cancels out by the y. And I get y equals 12 divided by 6 is 2. Alright, so then my last step here, after I solve for y, is just saying that y is the y-intercept. And that's all we have to do there. Alright, so now, what if I wanted to graph this? Okay, first I need some graph paper. So I'm going to pause and get some graph paper really quick. All right, got my graph paper. So what we can actually do now is try to jimmy rig this a little bit. we can graph after finding our x and y intercepts. And you might be asked to graph given x and you might be asked to find x and y intercepts and then graph after doing that. So when you find an x-intercept, okay, it's just a number technically, okay, but you can write it as a point, okay? Every point is an x, y coordinate. So we put our x value in the first number, so we said 6. And for our y value, well, what do we put in for y here? We put 0 in, right? We said that for the x-intercept, y equals 0. Okay, so that's one of the points we're going to graph. And then we will graph our y-intercept. Okay, we said that y is 2, so our second value would be 2, and we put 0 in for x because in a y-intercept, x is 0. Now that I have these 2 points, okay, I only technically need 2 points to graph a line. So if I bring over my graph paper, okay, 6, 0 means I'm going to go 6 in the, let's get our axes labeled x, y. 6 in the x direction, so 1, 2, 3, 4, 5, 6, and then 0 in the y. So I'm not going up or down, I'm staying right where I am and put a point there. Okay, now for the point 0, 2, I will go 0 in the x, y, or the x direction. So that doesn't mean I'm moving left or right at all. 2 means I'm going to go positive 2 in the y, which is up 2, and put a point. Okay, after I've done that, I can now draw the line between those 2 points, and I will use my sticky notes to do that the best that I can. Okay, try to use a straight edge. We'll get the most accurate graphs. Put your arrows on the end. All right, so after you find your x and y intercepts by setting y equals 0 and x equals 0, you'll get these 2 points. Put them on the graph, draw the line between them, and you can graph that way. Another way we can graph linear equations, right? Another way we can do it is to use a table of values. So let's talk about graphing using a table of values. So think about what a table of values looks like. Table of values has x values and y values. Okay, I'm going to put 3 rows. Okay, so I'm going to get 3 xy pairs. X, y, x, y, x, y. Let's use, I don't know, I gotta make up an equation. 4x minus 2y equals 16. How about that? Okay, so I'm gonna graph this using this table of values. So to fill out this table of values, okay, what you're going to do is you're going to pick x values or y values. So let's say we pick, I always suggest you start with putting 0 as x. Okay, so pick 0 for x. So what that means is I'm going to use my equation and put 0 for my x. And now I will solve for y. 4 times 0 is 0. 0 minus 2y is negative 2y. I divide by negative 2 on both sides. That'll cancel, and I get y equals 16 divided by negative 2 is negative 8. So when I put x in for 0 here, I get y is negative 8. I put negative 8 for y. All right. Second number I suggest you put in is 0 for y. So I put 0 in for y. Okay, so I'm just doing 4x minus 2, put 0 in for y, equals 16. And now I solve for x. So now I have 4x minus, well, 2 times 0 is 0. 4x minus 0 is 4x. And now I divide by 4 to cancel out there. That means I divide by 4 here. and I got x equals 16 divided by 4 is 4. So when I put y is 0, I get x is 4. So I put 4 there. All right, that's why we start with the zeros. So 0 for x, 0 for y, because it works out really nicely almost every single time, okay? For the third one, you can pick any number for x and y. I think I'm just going to try 1 for x and see where that goes. If I get a decimal, I might try a different number, okay? But I'll start with 1 for x. So I can do 4 times x. Well, I said x is 1. So 4 times 1 minus 2y equals 16. Okay, 4 times 1 is 4. So I have 4 minus 2y is 16. Okay, I'm solving for y. I need to get rid of either the 4 or the negative 2 first. I need to get rid of the 4 first. It's a positive, so I subtract both sides, cancels. So now that canceled, I have negative 2y left. 16 minus 4 is 12. Divide by negative 2 on both sides. That'll cancel, and I get y equals 12 divided by negative 2. It's negative 6. So when I put x for 1 for y, I get negative 6. All right, so now I fill out my table of values. Now I have to graph it. So I'm going to right here. Let's see. I'll go the next one down. All right. So you might be thinking, well, we don't have any points right now. We do have points though. Okay. So what we have for points, okay, remember a point is an x, y value. So my point here, I use the x, I use the y, and I have a point. My next point, 4 for the x, 0 for the y. My next point, 1 for the x, negative 6 for the y. Okay? Now what I can do is put these points, 1, 2, 3, all 3 of these points on my graph. So 0, negative 8, so I start here. 0 on the x, so I don't move left and right. Negative 8 means down 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, next point, 4, 0. So I start here. I go positive 4 on the x, so 1, 2, 3, 4. 0 on the y, so I just put my point here, not moving up or down. Then my last point is 1, negative 6, so I go 1 on the x, negative 6 on the y, so down 6. 1, 2, 3, 4, 5, 6. Again, use a straight edge to draw your line. Put my arrows. And that is how you graph using a table of values. Right? So what we're going to talk about next is slope. All right? So now we're getting into more of 3-3. All right? So let's kind of section this off. We're going to talk about slope. So slope is a number that represents the steepness of a line. Okay? It's not a point. You're giving me a single number if you're giving slope. And there are 3 ways that we have kind of talked about slope. So slope is your change in y over your change in x. Okay? And that again is referring to your coordinate plane, x-axis, y-axis. Okay? Well, to find your change in y, you do y2 minus y1 over x2 minus x1. So when you think of change, think of difference, subtraction. Okay? So these are referring to 2 points. That should be y. So 2 points, my point, x1, y1, so 2 different values. and then my second point, x2, y2. So you subtract the y's, and then you put that over the subtraction of the x's, and that's how you find the slope of 2 points. Another way we've talked about it is rise over run. So rise being my up and down movements, run being my left and right. Okay, because run is with the x's, rise is with the y's. So let's talk about finding slope from a graph first. So let's find the slope of this line that we have already drawn. Okay, so a couple ways we can find slope here. I tend to do rise over run here. I'm gonna write rise over run. So my rise, so let's start by this. To find the slope on a graph, this is probably the easiest way to do it. So first, start at left point, okay? So pick a point that's more to the left, okay? We have 2 points here, so I'll start at my leftmost point. Okay, next is count your rise. So your movement up or down. All right. So my rise here is down 1, 2. Okay, because I'm going from this point to this point. Finding how I get from here to here. I go down 2. So my rise is down 2. Down is a negative. Then I need to count my run. So that if I start my leftmost point, it will be moving left, so it'll always be positive. So I go left, 1, 2, 3, 4, 5, 6. So my run is 6. The last thing you need to do is reduce. Always reduce your slope, okay? So if I have a slope of negative 2 over 6, top and bottom can both be divided by 2. And I get negative 1 over 3. All right? So this would be my slope. Okay? So let's do the same thing here. We'll start at a left point, and we have 2 points here that be considered left if we want to end at this point. Or we could find the slope from this point to that point. That might be easier. Let's do that. So we start at our leftmost point, count our rise. So we go up 2. So our rise is 2. All right, so let's see. Let's write this again. Rise over run. So I went up 2, rise 2, over 1. So my run is 1. And now I reduce. 2 over 1 is 2. So slope is 2. Now remember, this is something we really didn't say before here. Slope is always represented using the variable m, okay? So if we're just given a single letter, slope will always be m, okay? So here, my slope is 2, I would say m equals 2. Here, if my slope is negative 1/3, I would say m equals negative 1/3. All right, so that's how you find slope from a graph. Now let's talk about finding slope from 2 points. Okay, so let's say that my points that I am looking at are 1, 3, and 3, 8. All right, so to find my slope, I'm going to use this one here. Okay, so I'm going to use this along with this, and I'm going to use it here. Okay, so what I'm going to do is I'm going to pick one of these points to be my first point. So I'll pick this to be my first point because it's listed first. Then I'll pick this to be my second point. Okay? To find my slope, it says y2 minus y1 over x2 minus x1. And that'll give me the slope. Okay, so slope equals this. Right? So y2 is the y value of my second point, so it would be 8. y1 would be the y value of my first point, which would be 3. So I do 8 minus 3, put that over, now I do x2, so x value for my second point, 3, minus x1, so the x value of my first point, 1. Okay, 8 minus 3 is 5, 3 minus 1 is 2. Can this reduce? Nope. So that is m, or I could say m is 5 over 2. Remember, m is slope. So that's how you find slope from 2 points. Not too difficult. Okay, last thing with finding slopes, there's another kind of slope that we should talk, or another way of finding slope that we should talk about, is finding slope from a table of values. Right? So I'm going to copy that down here. And we will find the slope of that line that we had drawn before. So 0, -8, 4, 0, 1, -6. Okay, so to find our slope here, you have to remember that slope equals change in y over change in x. So what I'm going to do is I'm going to look at my y's. How do I get from -8 to 0? Well, I have to add 8. Okay, so that would be my change in y. Now I look how I get my change in x's. How do I get from 0 to 4? Well, I add 4. So that would be my change in x. So I put that here. And now I reduce that. 8 divided by 4 is 2. So m, my slope, is 2. And I could have done that between these 2 points. Okay, 0 to -6. I subtract 6. 4 to 1. I subtract 3. So this would be my change in y. This would be my change in x. -6 divided by -3 is 2. Slope stays the same. And then I could do the same thing going from the top row to the bottom row, okay? Your slope is going to be constant in a linear equation. All right, big point to remember. Okay, next, what we'll talk about, let me get another piece of paper, sorry, is we can talk about 4-1 now, which is slope-intercept form. All right, so slope-intercept form is y equals mx plus b, where m is slope, b is my y-intercept. Okay, so slope-intercept form. That's why it's called slope-intercept form. Has my slope, has my y-intercept. Okay, so if I were to say, write an equation for a line with slope -1/3 and y-intercept -3, okay? Oh, I don't want that period there. I want that in slope-intercept form, okay? That's right, because we're talking about slope-intercept. Okay, so to do that, my y and my x's are still variables, so they'll stay there. I just need to find my m, which is slope, and my b, which is y-intercept. So my m, slope, well, my slope is negative 1/3. Right? Slope is m, negative 1/3 there. And then I need to put my y-intercept. My y-intercept is negative 3. So y equals negative 1/3 x minus 3. That would be my answer. Okay? Now, what if I gave you a graph of an equation? Can we figure out the slope-intercept form from that? So what if let me just graph something quick. I don't know what my slope or my intercept are here at this exact moment, but I just want to get something quickly drawn for us to use. Okay, not exactly perfect. All right, so if I want to find okay, if I'm looking at this graph, I'm going to say write the equation of the graph line in slope-intercept form. Okay, what are the two things we need for slope-intercept form? Well, we need slope, and we also need the y-intercept. Okay, so let's look at this graph. What is the slope? Okay, well, to find the slope, we start at the leftmost point, check our rise, so we go 1, 2, 3 up, so my rise is 3, because slope is rise over run. So I go up 3, and I go over 1, 2, 3, so my run is 3. And then I reduce. 3 divided by 3, that's 1. So my slope is 1. Now I need to find my y-intercept. Y-intercept is where the graph crosses the y-axis. Y-axis, graph crosses it at this point. Well, what does y equal at that point? 1, 2, 3. So my y-intercept is 3. Now I can write my equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So y equals slope x plus y-intercept. All right, so y equals slope x plus y-intercept. And then you can also write that as this. These are the same thing, right? Our 1 just disappears here. We don't have to write the 1. And that would be your answer there. Okay? So last thing we can talk about with slope-intercept form is graphing based or given slope-intercept form, okay? So let's do y equals negative 1/2 x plus 4. So we're going to graph that. So to graph, let's see, the first thing you want to do is put in the y-intercept. Okay, remember, slope-intercept form gives us the y-intercept. The y-intercept is right there. It's a plus 4. So I am going to go up 4, 1, 2, 3, 4 on the y-axis, right? Because it's y-intercept. So I'm going to the y-axis. Okay, put that point in. Next thing I'm going to do, use slope to find another point. Okay? Hint here, remember when we're graphing, always think rise over run. Okay? It'll make things a lot easier when you graph. Okay? So our slope here, okay, so slope is rise over run. Okay, our slope is -1 over 2. Okay, so a rise of -1 means down 1. A run of 2 means over 2. And over meaning to the right, positive, okay? So I'm going to start at this point, and I'm going to go down 1, and I'm going to go over 2. So down 1 over 2, I get a point. Third step, repeat until you can't anymore. Okay, so I'm going to keep doing this with these points. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Okay? Fourth step. Go back to your y-intercept and do in reverse. Okay, so in this case, the reverse of down 1 over 2 is up 1, back 2. Back being to the left. So I'm going to come back here and I'm going to go up 1, back 2, up 1, back 2, up 1, back 2, up 1, back 2, up 1, back 2. Okay? Then I can get my straight edge. And mine's not long enough, but I will do my best. Draw your arrows. And that's how you graph given an equation. Always check to make sure your graph makes sense with your equation, okay? Look at my slope. It's negative, okay? Remember slope, dude. It was puff, puff, positive, nice, negative. This is 0, fun, undefined. So undefined, 0, negative, positive. So downhill is negative. All right. Actually, one last thing I want to talk about is it has to do with slope-intercept form. It's this little acronym. Hoi Vux. Okay, so this is going to help you with some funny looking linear equations and what their graphs looks like. So Hoi, the H stands for horizontal. So if I have a graph, horizontal line, okay? The O stands for zero slope, okay? So that has a slope of 0, which we know that was slope, dude. The Y tells us what the equation is going to look like. Y equals a constant. So Y equals any number. So I'll say 2. Okay, if we say that this is 2 right here and this is 1, Y equals 2 would be that equation. The equation for this little line here. Okay, so that's Hoi. Horizontal, 0 slope, Y equals a constant. Vux, instead of horizontal, we're talking now vertical. Okay, so if I were to graph it, it would be something like that. Let's say that this is 3. Instead of a 0 slope, we now have an undefined slope. So a vertical slope is undefined, which we know what slope do. Lastly, this last one tells us what the equation look like. X equals a constant. So here, x equals 3, and that would be the equation of this vertical line. I'm sorry about the chord there. So these little things, Hoi Vux, if you see an equation that's just x equals or y equals, it's sometimes really hard to remember what the slope is, what it looks like, how to graph it. These super, super helpful in remembering that. Okay, so if you see an equation y equals 2, go over to y equals 2 and draw your horizontal line. If you see an equation x equals 3, go to where x is 3, draw your vertical line, and that's how you'd graph it. Okay? Video was super long, but I really hope that helped with standard EF.